Okay, this is a video for chapter 6 and 7 test. I'm going to go over the review problems, and the test problems will be pretty much similar to some of these problems, so make sure you know how to do this. And if you need explanation for a specific problem, you might want to use the timestamps in the comments. Okay, I'm going to start with 6.21. They want you to find the ratio of koi to goldfish in the pond, and the ratio is 3 to 11, which adds up to 14. There are 70 fish in total in the pond, and how many koi do I have? Well, koi is 3, and 3 out of 14, which is total number, not actual number, but it gives you fraction for koi out of the total, right? If you multiply that number by 70, which is the total actual number, then this will reduce to this, and it'll be 5. 14 goes into 70 5 times. 3 times 5 will be 15, and that's the answer for 21. Moving on to 22. My baseball team won 3/5 of its games. If they won 3/5 of the game, the rest of them they lost, which is 2/5. 1 minus 3/5 is 2/5, right? Now, they gave you actual number of games lost, which is 24. So 2/5, which is the fraction for lost games, multiplied by the unknown number of total games. The total number of games which is unknown is supposed to be 24. I can get this t value by multiplying the reciprocal on both sides, and that gets rid of the fractions, and t alone will be, well, 2 goes in there 12 times, so 12 times 5 will be 60. But we're not looking for the total number of games. The final question, always read the final question, okay? How many games did we win? We know out of this 60, 24 games were lost, which leaves you 36 games, which is the number of games they won. Or you could think of it this way too. Well, they said 2/5 of the total number of games is 24. Then 1/5, which is half of 2/5, will be half of 24, which is 12 games, right? Now, if 1/5 of the games is 12 games, 3/5 of the games, which is 1, the games they won, will be 3 times 12 games, which is 36. That's more of a intuitive way, and it could be a little faster. Now I'm going to move on to percentage questions. So number 23. These questions you can just translate as you read. What number means x is equal. 15% is 15%, since percentage is not really a actual number, so I need to divide by 100 to change it to fraction, or you can use 0.15, but in this case, a fraction might be better than decimal number, right? And you know all is multiplication, and 26. So if you try to reduce 15 with 5, which is 5 times 3, and 5 goes in here 20 times, and well, I could keep reducing this because 2 goes in there 10 times, 2 goes in here 13 times, right? So that will be 3 times 13, which is 39 over 10, which is the same thing as 3.9, and that's the answer. Next question. What number x is equal 20%, 20% of multiplication, 150%, which is 150% again, of another multiplication, 60. Well, it's a lot of zeros, right? So let me try to reduce these. 1 0 by 1 0. 1 0 by 1 0. Now, I think I can divide this into 5. So it will be 5 times 2 is 10. And 5 times 3 is 15. And I think I can reduce this 2 and that 2. And finally, I can reduce this 10 and this 60, and 10 goes in here 6 times, right? Wow, it's kind of messy, but you see that all numbers are gone except 3 and 6, which multiplies to be 18. That's the answer. Next question, 6.24. What percent? So that's a known percentage, right? But still, that's percentages. So I'm gonna do x over 100, right? So I'm treating this x as a percentage, okay? Of is again multiplication. 75 is equal 30. Well, let me try to leave x alone. Before I do that, I think I can reduce these two numbers. 25 goes into 75 3 times and 4 times here. So that's basically 3/4 of x, and that should equal 30. And again, I can multiply by the reciprocal to get rid of this fraction, and multiply the same reciprocal on the right side, and as intended, these will be gone, leaving x alone, and the right side will reduce. 3 goes into 30 10 times. 10 times 4 is 40, but that's not just 40. I started with x being the percentages, so that's 40%, which is the answer. Okay, now B, what percent of 20 is 12 and 1/2? So what percent of 20 is 12 and 1/2? Well, let me try to change this into improper fraction. Okay, and this will be then 25 over 2 instead of 12 and 1/2, right? Now, I can reduce these two at this point. 20 goes into 100 5 times. So if I rearrange this question, it will be x over 5 should equal 25 over 2. I need to find x, so I'm gonna multiply 5 to get rid of the denominator 5 and multiply the same number here. So that will be gone, and this is 25 times 5, which is 125 and over 2. Or you can put that into decimal number. Half of 125 is 62.5, and don't forget that this is percentage as well. Okay, moving on to 6.25. Now 48 is 37.5. That's 37.5 again percent of multiplication. What number? Okay, I have decimal number and fraction. I don't like it, so I'm gonna make it just fraction, okay, without decimal, by the way. So 48 will still be 48 on the left side, but Let me multiply this by 10 to make it 375 instead of 37.5. Then I have to be fair and multiply this denominator by 10, which will add one more zero, right? 1000. Well, think of, oh, by the way, this is times x. And let me try to reduce this. We know 375 is like $3.75, right? And 1000 is like $10, right? So 375 has, how many quarters is that? How many 25 cents does it have? If it's 375 cents, which is $3.75. Well, $3 has 4 quarters, and we have 75 cents, which is 3 quarters, right? Or did I confuse you? Okay. $3 has 12 quarters, and 75 cents has 3 quarters. That's altogether 15 quarters, right? Now, 1000 cents, which is $10. Well, each dollar has 4 quarters, so $10 should be 40 quarters, right? And they happen to reduce again because 5 goes into 15 3 times, 5 goes to 40 8 times. So far we have 48 equals 3 over 8x. Now I need to find x alone, right? So I'm going to multiply by the reciprocal 8 over 3 and 8 over 3 here. Okay? So these will be gone, leaving x alone. And if I reduce this part, 3 goes into 48 16 times. And if I multiply 8 by 16, that's going to be 128, which is the final answer. Moving on to B. 1/2 is 140% of what number? This is simpler actually. So I'm going to reduce 0, 0, and 2 goes in there 5 times, 2 goes in there 7 times. So far I have 1/2 equals 7 over 5x. So if I multiply by reciprocal 5 over 7 and same reciprocal 5 over 7, that's gonna get rid of this, leaving x alone, and this reduced to be, it does not reduce but multiplies to be 5 over 14, and that's the answer for B. Moving on to 6.26. Alright, 1 liter of soda contains 450 calories. There is a conversion factor right there. So 1 liter should equal 450 calories. Now, how many calories are in 250 milliliters of soda? So we always, this is by the way, unit conversion by multiply by 1 and both, right? And always start with the given amount or given measurement. So I'm going to start with 250 milliliter, which is given, and well, they give us one more conversion factor. They said 1000 milliliter equals 1 liter. We kind of knew that, but I guess we can use it right now because I'm going to multiply by 1 using conversion factor, right? And they said 1 liter equals 1000 milliliter. I'm going to put milliliter on the bottom. Why? So that these units can reduce later, okay? And I'm going to put liter on the top. And they said 1 liter equals 1000 milliliter. Now, my final destination should be how many calories. So we should be finding the calories, right? Well, we're going to use this conversion factor this time. So I'm going to put 1 liter on the bottom so that the liters will reduce again. And I'm going to put 450 calories because 1 liter is same thing as 450 calories according to this, right? Now, all I have here is number of calories. All we have to do is multiply these and divide by 1000 and multiply this, right? And I think 250 goes into 1000 4 times, right? So it'll be 450 divided by 4. And that's going to be in decimal 112.5. What's the unit? Calories. That will be the answer. Now, 6.27. How many minutes are in 20% of a day? 20% is 20 out of 100. And of is multiplication. A day is 1 day, right? But I want to convert that into minutes. We don't really know how many minutes there are in 1 day. So I'm going to convert little by little. I'm going to multiply by 1 using conversion factor. I'm going to put day on the bottom and number of hour on the top. Because we know 1 day has 24 hours, right? Now, it's not minutes yet. So I'm going to multiply one more embo, okay? And we know 1 hour has 60 minutes. Why did I put hour on the bottom and minute on the top? So that day will reduce, hour will reduce, leaving only number of minutes on the top, right? And we know 20 goes in there 5 times, and 5 goes into 60 12 times. It's all reduced. So we just need to multiply these two numbers, right? And then the unit will be minutes. And 24 times 12 is 288. And that's number of days. Number of minutes in 1 day. Now 6.28. All right. So we have two 600 milliliter pitchers. 1, 2. Kind of crooked, but I guess it's okay. Both are having capacity of 600 milliliters, right? And they said one pitcher is 1/3 full, and the other is 2/5 full, right? Well, what is 1/3 of 600? It's gonna be 200, right? And what is 2/5 of 600? Since 5 goes in there 120 times, 2 times 120, that will be 240. So that's how much orange juice we have, right? Now I'm gonna fill water into this. Water is added to fill each pitcher completely. So all the way to the brim. All the way to the brim, right? So this is water added and this is water added, right? That means we have 600 milliliter of mixture here and another 600 milliliter of mixture right there, right? And they're asking you what fraction of the total mixture in the large container, because they're all poured into one large container, right? One large container. I'm going to put all of this, which is 600 plus 600, right? So total mixture will be 1200. But out of that, what fraction of the mixture, which is 1200, is orange juice? We know orange juice was what? 200 and 240, which adds up to 440, right? So if I reduce this on and on and on, we will get 11 out of 30. If you ever wonder, you can try yourself, right? 0 reduces 22, 60, one more time, 11, 30, right? So that should be the final answer. Next question, 6.29. My supersonic jet burns 4 gallons. 4 gallons of jet fuel in 3 seconds, right? So every 3 seconds, it burns 4 gallons. That's a lot. No wonder it's a jet, right? Now, the question is how many gallons? So gallon does not change. Gallon is still gallon. How many gallons of jet fuel do I need to fly for an hour? I guess I can just multiply this by 60 and 60 because 60 minutes and 60. Anyway, so we're gonna multiply. Let's try EMBO right here. So if I multiply second and minute first, that's gonna be 60 seconds in 1 minute, right? So second will be gone, and we have to find an hour. So I'm gonna put minute on the top and hour on the bottom, right? So that minute will be gone, and we know 1 hour has 60 minutes, right? Yeah. So the only unit we have is gallon per hour. All other units are reduced, right? That's how we do unit conversion using EMBO multiplied by 1, right? Now, 3 goes into 60 20 times, and 4 times 20 is 80. 80 times 60 will be, that's 4,800 gallon per hour, right? So that's the final answer. That's a lot of gallons of fuel, right? Bad for environment, by the way. All right, 6.31. I need 40 square yards, that's area unit, right? Of cloth to make curtains for my room. Unfortunately, the store only sells cloth in square meters. That's different units, right? It's both area, but one is square yard and the other is square meters, right? And they're saying there are 0.9144 meters in each yard. That is 1 yard. So 1 yard equals 0.9144 meters. The problem here is these are length units, right? 1 yard equals 0.9144 meter. Those are length. Now, how do we convert that into area ratio? Simply square it and square the right side too. That's gonna give you 1 square, because 1 square is still 1, right? 1 square yard equals, if you do the calculation, let's try this. So 0.9144. Do you see the numbers? It's kind of small, but you can see it, right? And if you square that, that's gonna be 0.83613. So 0.83613 blah blah, right? Square meters. So now I have area ratio between yards and meter, right? I'm gonna have to use this one to convert it, right? So how many square yards do we need? I need 40 square yards, right? And how am I gonna convert that into square meters? Multiply by 1 again. So I'm gonna put square yard on the bottom, which is 1 square yard equals 0.83613 square meter, by the way. So let me use calculator one more time. So it'll be 8.3613 multiply that by 40 right here. 40, that will give you 33 point rounded 45, right? So 33.45 squared meter will be the answer. Well, uh, in the test, you're not going to be using calculator, so I'll give you conversion factor that is simple enough without like this messy decimal numbers. So don't worry about it, okay? Something like square feet and square yard, right? Because 1 square yard equals 9 square feet. That's no decimal, right? Moving on to 33. All right. The question says 2/3 of the people in a room. So 2/3 of people. P stands for the total number of people in the room, okay? Are seated in 3/4 of the chairs. So 3/4 of the chairs. Now these should be equal, right? The number of people who are seated and number of chairs that are taken, right, occupied, should be same, right? Because those chairs are seated by people who are sitting, right? Now, the rest of the people are standing, which is probably 1/3 people, right? If there are 6 empty chairs, now, when 3/4 of the chairs are occupied, we only have 1/4. The rest of the chairs that is not occupied yet, empty chairs, will be 1/4 of the total number of chairs, right? And how many is that? That's 6 of them. Hey, that gives you C value right here. Because if I multiply 4 and 4 on both sides, it will be C equals dung dung 24. So this should be the total number of chairs. Well, you can use this number and plug it in right here. So what is 3/4 of 24? It'll be 4 goes in there 6 times. So 3 times 6 will be 18, right? So 2/3 of people, which is this, should equal 18. And the final question is, how many people are in the room? So we need to find P alone. And again, that's reciprocal, 3/2. And same number multiplied here. And that will be gone. That's why we multiply by reciprocal, right? And the right side will be changed to 2 goes into 18. 9 times 3 is 27 is the P value, which is the number of people in the room. Now, 6.34 might seem a little harder, and it's like talking about reducing price by 20%. Sounds similar? I guess I'm going to use 1 plus minus R. 1 plus R for percent, increase. 1 minus R for percent, decrease. What is this good for? Instead of talking about percentage that is being reduced or increased, if I add that percentage in decimal number, by the way, the decimal value of the percentage, if I add that to 1, this value, 1 plus R, gives you new increased price directly. Okay? Because it adds to the original price, whatever that percentage that was increased. Same thing for 1 minus R, right? If I multiply 1 minus R, that gives you new decreased amount right away, okay? So this is what's going on. On Tuesday, already store reduces all its Monday price, which is the starting price or original price, by 20%. So let's say that Monday price is like M, which is original price, right? So new price will be 20% off, which leaves 80%. So 1 minus 0.2, which is 20%, will give you 0.8. So I'm going to multiply 0.8, and this is going to be the new decreased price, okay? Now, the question is, by what percent must the store reduce the new Tuesday price? So you're going to like do further reduction this time. And by what percent? Let's say that's R, okay? And if I do the same 1 minus whatever that r is, this will give you the new decreased price. One more time, okay? Further decreased price, right? And you want that to be such that each radio costs half its Monday price. Well, half is 0.5, 50%, right? Well, if you take 0.5 from 1, that's still 0.5, right? Half is gone, half is left, right? So this result should equal to half, which is 0.5 of whatever that Monday price is. So it's kind of messy, so let me just write this one more time. 1 minus r times the Tuesday price, which is 0.8 m. So it's all connected with multiplication and multiplication, right? Should equal 0.5 m here. Teacher, we have r and we have m. I would say we don't worry about m because I could reduce both sides by m, okay? Because it's all connected with multiplication, I can reduce one by one, right? Now the only variable I have is r. So if let me rewrite this. It will be 1 minus r times 0.8 should equal 0.5, right? So let me try to distribute this decimal number to this and to this. So 0.8 times 1 is still 0.8. And 0.8 times negative r is minus 0.8 r. Distribution, right? Expanding. Equals 0.5. I guess I could combine these two constant terms, which will be 0.3 on the left side. And I'm going to move this to the right side by adding 0.8 r to both sides. Okay, so 0.8 r. Okay, so if I solve for r, that will be r equals 0.3 divided by 0.8. And isn't that same thing as 3 over 8? If I multiply top and bottom by 10. Now, isn't 3 over 8, if you find the decimal value of that, by the way, it's going to be 0.375. Well, they want you to find by what percent. And since this is not percent but decimal number, I just need to multiply that by 100%. So the final answer will be 37.5%. Okay? That took a while. And it's kind of messy, but you see the answer, right? Next question, 6.36. Well, some students are taking a math contest in which each student takes one of the four tests. Right? Now, 1/3 of the students take the first test. 1/4 take the second test. 1/5 take the third test. And so far, let's add the fractions. The first test, 1/3 of the students. Second test, 1/4 of the students. And the third test, that's 1/5 of the students. If I add them all up, the common denominator will be 60, right? And 3 times 60, 3 times what is 60? 3 times 12 is 20 is 60. So I'm going to multiply the numerator by 20, which is 20. And 4 times what is 60? 4 times 15 is 60. So 1 times 50, 15, which is 15. And 5 times what is 60? 12, right? 5 times 12 is 60. So I'm going to multiply the same number, 12, on the top. 12, right? And what do they add up to? 20, 35, 47. So that's 47 out of 60. That's the fraction of the students taking the first or second or third, right? Now, don't we still have the fourth test right here, right? And that must be whatever the leftover from this, which is 1 minus 47 over 60, which gives you 13 over 60, isn't it? Because they add up to 1, right? Now, 13 out of 60 students took the fourth test. The fourth test, right? So if I make the total number of students T, 13 over 60 of total number of students should give you, hey, they gave you right here. 26 students took the fourth test, right? So 24, right? Hey, this is a solvable equation. I just need to leave T alone by multiplying reciprocal. And then same reciprocal on the right side, right? And these are gone. That was my intention. And by the way, is it 24? Oh, it was 26 students. I thought something was weird. So it was 26 students, right? I read the number wrong. Now, 13 goes into 26 twice, right? And 2 times 60 is, what is that? 120. That's the total number of students. And they were being divided into all these 4 different tests, right? Now 37. P is 50% of times Q. Well, simply that's 1/2, right? So I guess P equals 1/2 Q. And R is 40%, 40 out of 100 of times Q. Well, this reduces to 20 goes into 40 twice and 5 times here, right? So I guess R equals 2/5 Q. So let me use these two to answer this. What percent of R? So what percent of R is P? So I need to find what, which is X right here. Well, if I leave X alone right here, then R has to go down there and 100 has to be multiplied on top, right? So we know X equals P over R times 100, right? And we know P is what? 1/2 Q. So that would be 1/2 Q. And we know R is 2/5 Q, right? So R will be replaced with 2/5 Q and times it by 100. Almost done. Q and Q will be reduced. And 1/2 over 2/5, if we do the if we do the complex fraction, it will be 5 over 4, right? So 5, wow, let me reduce this. 5 over 4, it's so small. 5 over 4 times 100. So 4 goes in there 25 times. 5 times 25 will be the answer, which is 125, right? That should be the answer. So, and it is percentage. What percent? So that is 125% as the answer. Okay? It's kind of messy, but you got it, right? All right. Moving on to 6.38. Okay. The question is, how many pounds of water must be evaporated from 50 pounds of 3% solution? Well, let me get what I can get first. Right now, 3% of 50 pounds is pure salt solution, right? It's pure salt, right? So 50 goes in there twice. So I guess 3 over 2, which is same thing as 1.5, because it's 1.5. That's number of pound of actual salt, the pure substance, right? Now, we know there are two different ways to make it salt here, like increase the percentage of concentration from 3% to 5%, which is salt here, right? We could either add salt, right? And that's gonna increase solution by same amount because the solution includes salt. By adding more salt, the total solution, which includes salt, will also be increased by that much, right? But the other way to make it salt here is reducing water by evaporating water. Well, we have salt and we have solution, which is salt plus water. And if you subtract some amount of water from the denominator, that does not make any change on the salt amount, okay? So that's the biggest difference. So when you add more salt, that adds to the denominator as well by the same amount. But when you subtract water from the denominator, nothing changes on the numerator, okay? Now, didn't we have 1.5 pound of salt, which we could figure out from these two numbers? And wasn't that out of 50 pounds, which is the total mixture solution? Now, how much water should we subtract from that so that the new concentration will be not 3% this time, but 5% this time? Well, the numbers are kind of messy, so let me reduce this by 5 times. Oh, I guess I can just leave it like this because in a way 100 is a good number because 1.5 times 100 when you do cross multiplication, so you move the decimal number twice to the left because we have two zeros right here, so it'll be what, 150 should equal cross multiplication 5 times 50 minus w, right? Now let me move that here and I'm going to expand it, okay? So 150 equals, distribute it, 5 times 50, 250. 5 times w minus 5w, because there was a negative sign right there, right? Now, if I make this move to the left side, it will be 5w. And if I combine these two, which is 250 minus 150, it will be 100. So if I divide by 5 and 5, I guess w alone equals 20, and that's the amount of water to be evaporated from the denominator, which is the total solution. Okay, so 20 is the answer. Good question, right? And that is the end of chapter 6. So we're gonna move on to chapter 7, review problems now. Remember direct variation and inverse variation? Direct variation is where two things are increasing together or decreasing together. So if you increase numerator, denominator should be increased as well in order to make this quotient same, right? So a over b equals c over d is the direct variation case. And inverse variation, or it's also called inverse proportion, by the way. So direct proportion, inverse proportion, same thing, right? Inverse variation is a times b equals c times d. Why? Because if a is increased, b has to decrease in order to keep these products the same amount, right? So make sure you're not confused with these two, okay? So I'm going to move on to the first question, 7.17. They say S and T are directly proportional. So we're going to use S over T, okay? Increase case, right? Now S is 14. Let me put that on the top. And 12 for T. So that goes on the bottom. Now, what is S when T equals 7? Well, since this fraction should stay the same, and what is S? Well, S belongs to the numerator. That's how we set it up, right? that goes there, and 7 has to be down there because t is the denominator, right? Now, should we reduce first? Well, you don't have to, but it's better to use, easier to use small numbers. So 2 goes in there 7 times, 2 goes in there 6 times. So if I rewrite it, it'll be 7 over 6 equals s over 7. I could cross multiply 6s equals 7 times 7, 49. So s alone is 49 over 6, and that is the answer. Well, this time it is inversely proportional. So x and y are being multiplied this time. More of x, less of y, to make the product the same. So when x is tripled, well, the products always have to be x and y, x times y, xy, right? But when x is tripled, what should happen to y? Well, we have to get rid of this to make it back to xy. So y has to be 1/3 times, so that they will reduce and gives you back xy, right? This product has to stay the same all the time, right? So if you increased x by 3 times, you have to decrease y by 3 times. So the answer will be y should be divided by 3. Okay? That's the answer. Now for number 7.19, it's direct proportional, but you got to be careful. It's not just a, but a square and b, right? So a square over b will be directly proportional, right? Now when a is 2, b is 9. So a goes on the top of the denominator, but don't forget to square it, right? And b equals 9. That's just 9 right there. Now, what is b? So b should be down there. When a is 6, well, don't forget square again. So 6 squared, right? So that will be 2 squared, which is 4 over 9. And we know 6 squared equals 36 over b, right? So cross multiply says 4 times b should equal 9 times 36. Well, if I divide both sides by 4 to leave b alone, because that's what we have to find. And since this is multiplication, I can reduce 1 by 1. 4 goes in there 9 times. So the answer is 9 times 9, 81. That is the b value. And 7.20 is about distance and r, rate. Rate is speed, by the way, and t, right? And there are 3 formulas from the same idea. D equals, distance equals speed times time, right? And r equals, well, if you divide both sides by t, d over t. It's the same formula arranged in a different way. And t equals what? Well, same thing, d over r, right? So it depends on what we have to find, right? Now, the question is, Zhuang rides her bike to work. Good for her. Good for him. I don't know. The office is 8 miles from her home. Okay, that's the distance. So distance equals 8, right? And she rides 12 mph. Isn't that r, the speed? 12 miles per hour. Okay. At what time should she leave to get to work at 8 a.m.? So John has to get, it's French name, right? John. Anyway, has to get to work by 8 o'clock. Okay, so John has to leave early, right? Earlier than 8 a.m. Now let me figure out how long it takes. So t equals what? Distance divided by what? R, right? What was the distance, by the way? 8 miles, right? Well, sometimes they play around with the units, like Sometimes they do minute and hour mixture, so just be careful with that, right? But here it will be what was the speed? 12 miles per hour. So it's the same miles, right? So that's gonna be what? 2 out of 3, isn't it? Because 4 goes in there twice and 4 goes in there 3 times. So it's gonna be 2 over 3 hours, okay? 2 over 3 hours. Now, I think I need to convert that into minutes because that's confusing, right? It's fraction hour, right? So 2/3 hour multiplied by, EMBO from chapter 6, which was a long time ago. 1 hour equals 60 minutes, right? Or you can simplify 60, right? And that's gonna get rid of hour and give you minute, right? And 3 goes into there 20 times, so 2 times 20, that's 40 minutes, right? So it takes 40 minutes. It's 2/3 hour, and 2/3 hour is 40 minutes. So in order to get to work by 8, right? What time do you have to start? 7:20, right? 7:20 a.m. What a coincidence. The question was 7:20. I think that was intended. Funny AOPS, right? Number 7.21. A is directly proportional to B, but inversely proportional to C. So that means A over B, but A times C. If A equals 2, which is 2, and B equals 5, and C equals 9, so that's 18 right there. Then what is C when B equals 3? Well, the only place I see B is right here, so I'm going to use that one right there. So A over 3 instead of B should equal 2 over 5. That means A equals, if you multiply by 3 and 3 here, that's going to be A alone equals 6 over 5. So that's the A value. And I'm going to plug that 5 over 6 into this A this time. So that'll be 6 over 5 instead of A times C equals 18, right? So C in that case will be 18 times its reciprocal, which is 5 over 6. So 6 goes in here 3 times, and 3 times 5 equals 15. That's the answer for 21. 22. Homer began peeling a pile of 44 potatoes, that's the starting number, at the rate of 3 potatoes per minute. So every minute he can peel 3 potatoes. Now 4 minutes later, Kristen joined him and peeled at the rate of 5 potatoes per minute. So he's a little faster. Kristen is a little faster. Anyway, during the first 4 minutes, Homer peeled 3 potatoes per minute times 4 minutes. So that's going to be 12 potatoes, right? And that leaves 44 minus 12, which is 32 more potatoes to peel. Now, when Homer and Kristen work together, Homer can peel 3 potatoes per minute, and Kristen helping, Kristen can peel, Kristen can peel 5 potatoes per minute. So they can together peel 8 potatoes per minute, every minute, right? Now, how many minutes should be multiplied so that they can peel all the rest of the potatoes, which is 32. So this will be number of potatoes per minute working together multiplied by the number of minutes that is unknown should give you 32. That's simple, right? 8, 3 plus 5 is 8, times x equals 32. Dividing both sides by 8, that gives you x equals 4. Now, what's the question? Always read the final question, all right? Get full credit, not partial credit. When they finished, how many potatoes had Kristen peeled? So this 4 is 4 minutes, right? So during the 4 minutes, Kristen peeled 5 potatoes per minute multiplied by 4 minutes, right? So 5 per minute multiplied by 4. So the final answer is 20 potatoes peeled by Kristen. 7.23. On a certain map, 4 inches represent 26 miles. Now, what distance does 11 inches represent? This is a typical direct variation because more inches on a map means more actual miles, right? So I'm going to put 4 inch on the top, 26 mile on the bottom. So more inches, more miles, right? And that should equal 11 inches. That should go on the top because numerator is inches, right? We set it up that way. And that's going to be what distance actually? X miles, right? So it's basically 4 over 26 equals 11 over x. And 4 can be reduced into 2 and 26, 13, isn't it? So cross multiply, 2x equals, what's 13 times 11? 143, right? 143. So if you divide that into 2, x alone will be 71.5 miles. Now, number 27. I can finish the problems in one chapter. One person, can finish the problems in one chapter of my physics book in 8 hours. Okay? Suppose that the problems in each chapter take the same amount of time to solve, and there are 30 chapters. How many people working together at the same rate as me would it take to finish the whole book in one day? One day, by the way, if I try to use the same unit as this, which is hours, will be 24 hours, obviously, right? So I guess there are 3 things here. So number of chapters and number of hour it takes and number of people to solve together. Number of hours and number of chapters, it could be direct variation, right? Because more hour, more chapters, right? To solve more chapters, we need more hours, right? That's direct proportion. And between number of chapters and number of people, well, if you have more people, then you can do more chapters, right? So that's also direct variation, right? But how about H and P, number of hours and the number of people? having more people to solve together means it's gonna take less time to finish it, right? So this is joint variation, by the way, joint proportion, where C is directly proportional, so to H, so H should go down there so that they're directly proportional, and C and P are also directly proportional, right? Now, when I was working all by myself, which is just one person for P, and doing one chapter, that's on the top, one chapter, and it took how many hours? 8 hours, right? So this ratio should still remain the same, right? And that should equal, now I have 30 chapters to finish, which is on the top, 30 chapters. And how many people do we need? So P is something we have to find, and the time given to us is 24 hours, which is 1 day, right? Now this is a solvable equation, isn't it? Let me try. 1/8 should equal, well, does this reduce? 6 goes in there 5 times, 6 goes into 24 4 times, so it'll be 5/4P. So if I do cross multiplication, it will be 4P equals 40. That leaves P equals 10. So we need 10 people to finish 30 chapters in 1 day, or 24 hours. Moving on to 7.28. It says each worker can paint my new house alone in 12 hours. Well, every hour, one good worker can only paint 1 out of 12 of my house, right? Per hour, right? And each bad worker, so one bad worker can paint my house alone in 36 hours. It takes 3 times longer, right? So every hour, the speed is 1 out of 36 can be done by one bad worker every hour, right? Now, I need my house painted in 3 hours to paint the whole house. If I can only find 3 good workers, so there are 3 good workers, how many bad workers must I also find? So how many bad workers should we add to those 3 good workers in order to finish it on time, right? So now let's focus on how much can be done every hour by good workers and bad workers together. Well, each good worker can do 1 out of 12 of the job, right? And there are 3 of them, so 3 times of that can be done, right? Plus, all those slower, they're gonna still be helpful, right? The bad workers. 1 out of 36 can be done by each bad worker. And how many of them are there? We don't know. That's what we have to find. So this whole thing will be how much can be done with the bad workers and good workers combined all together. Now, that's for every hour. So if you multiply that by 3 hours, which is the time we have, that should complete the house, which is 1, meaning the whole house, right? Now, it looks complicated, so let me try to divide both sides by 3. Okay, and this times this, 1/12 times 3, 3 goes in there 4 times, so it'll be what? 1/4 plus 1/36x equals 1/3. Okay, that's not too bad, because let me move this a little bit right here. Oops. Okay, one more time. All right, that's better. Okay, now I think I can combine these two, right? This and this. So I'm gonna leave 1/36x on the left side, and if I do 1/3 minus 1/4, since the common denominator is 12, and 3 times 4 is 12, so 4 minus 4 times 3 is 12, so 3, that's 1 out of 12, right? So if I rewrite that, it'll be 1/36x equals 1 out of 12. So if I multiply both sides by 36 and 36, and that's gonna be gone, of course, leaving x alone on the left side, and 12 goes in there 3 times, so the answer is 3 bad workers to be added. That was quite complicated. And I would say either 7.28 or 7.29 would be a good candidate for the bonus question in the test, okay? So I'm going to move on to 7.29. Another candidate for bonus question. Jane drove 20 mph, that's speed, right? So I guess this is about distance equals r times t problem, right? To her parents' house, grandparents' house, right? So from Jane's place all the way to grandparents' house. Now, the question is, how fast must she drive on the return trip to average 30 miles per hour for the round trip? So I guess she's going back and forth, and the average rate or average speed of the entire trip should be 30, right? Now, in order to find average rate, you have to divide the total distance, divide by total time taken. Now, what's the total distance? Let's say this distance between Jane's house and grandparents' house, let's make that, we don't know it, so it'll be d, some unknown distance, right? And when she was going to grandparents' house, how fast was she? 20 miles per hour. But when she comes back, we don't know, that's x, right? Now, the total distance will be d and also d, so it'll be d plus d, going back and forth, right? So it'll be 2d. But now, how do we find the total time? I think it's better to find this separately, because going to grandparents' house, it was the same distance d divided by 20. And it'll take more time to come back, so we're gonna add, it's gonna be same distance traveled, but this time we don't know the speed, right? Now, you want that entire trip average speed to be 30, right? Oh, that's a little complicated. Well, let me try to combine it though. That's 2d right there, 2d, or this is complex fraction, so let me just make it over 1, okay? It's easier that way with complex fraction. And since they have 20 here, but not x, I'm going to multiply x. And since this one doesn't have 20, I'm going to multiply 20, 20. Well, then this is going to be 20x on the denominator, and it will be x plus 20, and factor out d, because they both have d, right? And you know, you can reduce these to d's. Okay, and then we can multiply top and bottom, which is 40x divided by the middle 2 will be x plus 20, isn't it? It makes sense, right? Now, that should equal what? 30, which is same thing as 30 over 1. So if I do cross multiply, 40x times 1, which is 40x, should equal 30 times x plus 20, right? And if I distribute it, it will be 30x plus 600 should equal 40x on the left side. I think I can combine these two, will be 10x equals 600 on the right side. So if I divide both sides by 10 and 10, x now is 60 mile per hour. 30. Joe and Renee are building a fence. Joe can build a fence alone in 4 hours. So it takes 4 hours for Joe to work alone. If Renee starts helping Joe, so working together, after he has already worked on the fence for 2 hours, they will finish the fence 90 minutes. Well, isn't 90 minutes 1.5 hours, which is something as 1.5 hours, right? It takes 90 minutes after she joins him, meaning working together, right? How long would it take? How long would it take if Renee were to build? If Renee built a house alone, assuming Renee working alone, then how long would it take? Well, this is quite complicated, but let's try to figure it out right here. Now, Joe, let's figure out Joe's speed. How much can Joe do every hour if he takes 4 hours alone? If he works alone, he's gonna be able to paint 1/4 of the, he can build the fence. He can build 1/4 of the fence, right? Per hour, right? That's the speed for Joe. How about Renee? We don't know. That's why we have to find out. But let's say it takes X hours, right? For Renee to work alone. Then it's going to be 1 out of X can be done every hour, right? Now, Joe was already working for 2 hours. So 1/4 per hour times 2 hours, that means that's 1/2 of the job done, isn't it? So they only need to do like 1/2 more job, right? Now, since they're working together, Joe is painting 1/4 of the job per hour, and Renee is painting 1/x much of the job every hour, and you're gonna multiply that by the time given to them, which is 3 out of 2 hours, which is 90 minutes, right? Now, the result should be working together for this long. They have to finish the rest of the job, which is 1/2 of the fence. So that's the formula, right? That's the equation. And again, let me leave this parenthesis alone by multiplying by reciprocal here, 2/3. So this will be gone. So we have what? 1/4. Let me work without parentheses, by the way. 1/4 plus 1x, which is this parenthesis alone, should now be, since they're gone, it'll be 2 gone, 1/3 on the right side. Now, uh, leave 1 over x alone on the left side, and you're going to subtract 1/3 minus 1/4, which is 1 out of 12, right? So find the common denominator is going to be 12. 4 minus 3, it will be 1, right? Now, if 1 over x equals 1 over 12, don't you think x will be 12 by reciprocating both of these? It's 1 over x equals 1 over 12. That means reciprocal of 1 over x, which is x, should equal reciprocal of 1 over 12, which is 12. So 12 is the answer. So it will take 12 hours if Renee works alone to finish the whole job. Okay? Now the last problem. 8 workers can clear 20 acres of a field in 3 days. So we have number of workers and number of acres, kind of rhymes, and number of days, which is time it takes, right? And let's think about the relationship. More workers can do more acres, right? They can clear more acres if they have more workers. That's direct variation, isn't it? Now, if there are more days given to them, they can clear more acres too. That's also direct variation. But if they have more workers and to clear the same acres, more workers can take less time, right? So more workers, less time, less number of days. That's inverse variation right there. So this is another joint variation problem. And since acre is directly proportional to workers and directly proportional to days, this is what I'm going to do. I'm going to put A on the top and W on the bottom and D on the bottom too, so that A and W, acres and workers, are directly proportional, and acres and days is directly proportional, right? Now, what number did they give you? 8 workers, that's W. So 8 workers right there can clear 20 acres. That's right here, A acres, right? 20 right there. And that took how long? 3 days, right? And this number should stay the same all the time. Now, how many workers? That's asking W. Are needed to clear 50 acres. That's on the top. In 5 days. That's D. So that's 5 right there. Okay? So let's do a calculation here. 4 goes in, I'm trying to make the number smaller. 4 times 2 is 8. 4 times 5 is 20. And 5 goes in here 10 times. So overall it will be 5 on the top over 2 times 3, that's 6, equals 10 over W. 10 over W. Cross multiply time, cross multiply. So 5W should equal 60. And if I divide both sides by 5 and 5, W will equal 12, right? So that's the final answer for number 33. Yeah, so that is it. So I'm gonna see you in class. Bye.